Okay, in this video we're going to go ahead and take a look at just using the law of cosines, and then later on there will be a video proving out the law of cosines later. But for right now, we got the law of cosines up here, and it depends on what angle that you choose and the position of the sides that are going to go ahead and determine what values to place in for A, B, and C, and then the correct angle that you're taking the cosine of. So let's go ahead and just take a look at its makeup first, okay, rather than going right into the calculations. First of all is that, and even if I got rid of some values right here, so I'm just going to get rid of these values and come back to them, just to get rid of that, okay, and we'll come back to that in a minute. But notice that about the law of cosines is that angle A right here and this is going to go ahead and have to be opposite, all right, and of one another, and the B and the C, okay, are going to be the included sides, okay, that make up the angle that you're taking the cosine of, okay. So it's always, the makeup is the side that is opposite of the angle, okay, and then all of these B's and C's right here are going to be the sides that are going to make up the included angle A, okay. So that's how you fill in things correctly if you don't have all the A, B, and C, everything already, kind of laid out for you. All right, so let's get started with putting some numerical values to this and seeing how it works. Okay, so here we go. So looking at this, and one thing that I want to make sure that is a common mistake for folks using the law of cosines is that when you're solving a triangle with all sides, which is going to be the first one that we're going to take a look at on the left-hand side there, always start with the largest angle first. Quality of life note is that the largest angle is always across from the longest side. So angle B would be the correct place to start in this particular case. And so this would be the form that we are going to use for the law of cosines because it contains angle B and the sides that we need to make things work in the correct places. So let's fill this out and see where we are. Everything all set up. We got the cosine of angle B there, and that is going to be the thing in which we are solving for right now, again, because it's the largest angle, and we have all sides of the triangle that are given. And so what we need to do is that we're just going to clean things up. These are going to be some large numbers here, and so let's go ahead and square some of these out and move them to the left hand side. So squaring this out, and then we're going to move them to the left-hand side there, and that's going to give us, all right, looks like that's going to give us 101, okay, and then we have this part that needs to be cleaned up here, so when I multiply those all out, that's going to give me negative 224, and then cosine of B. And now I want to divide each side by negative 224. And that's going to give me the cosine B of, looks like I can't simplify that down, so this is going to give me the negative 101 over 224. And then to solve for angle B, we're going to take the inverse cosine of both sides, so we have B equals the inverse cosine of a negative 101 divided by 224, which is going to give us approximately 116 point, let's see, and so we're just going to call that 80 degrees. Okay, and so, and if you wanted to find the rest of the angles like A and C, you could repeat the entire process using the law of cosines for it. But I just wanted this to show you this example because that's how you would determine an angle using the law of cosines, okay? Kind of a slick thing considering we just have all sides and we're able to go ahead and fetch angles from there. We haven't been able to do that before, okay? Notice that we couldn't use the law of sines with this because we wouldn't have any angles that would be opposite any sides, or I should say any known angles that would be opposite any sides. So the law of cosines we would have to go ahead and use. Same thing with this guy over here is that we would need we have an angle, but we don't have a defined value, and then opposite it, we have an unknown angle and an defined value opposite it, and so we don't have that magic formula of a known angle across from a known side to start us off with the law of sines, and that's why it's important to use the law of cosines in these particular instances. So let's look on the right hand side and take a look at how to solve for a side using the law of cosines. So for this one, it looks like we're given angle A, so we're going to use this build right here. Okay. And let's fill that in and see where that takes us. Okay, so in this case, what we have to do basically is that we're going to take a look at just putting that into our calculator all at the same time, and then when we're done with that, we're going to get a squared equals some number. So let's go ahead and fetch that number real quick. It has a bunch of numbers after this that I'm not showing that's in the calculator there. So what I'm going to do is I'm going to take the square root of both sides, but I'm going to take the square root of it in my calculator for added accuracy, okay? And that is going to give me A is approximately 5.407, okay? So there we go. We end up with A, and that's going to be 5.407. And notice that, and even in both these examples, once you get, if you wanted to go on and find out what the other angles are, this guy and this guy over here, is that you can do so using the law of sines after that. If you feel like the law of cosines is a bit too laborious for you and whatnot, then you can go ahead and switch back and forth to the law of sines, so long as you have now, revealed the information where that's going to give you an angle and an opposite side from that, and then you can solve for the other angles. So that's how you do that, and let's go ahead and take a look at the next problem, which is going to need the law of cosines and a little bit of Math 2 skills in regards to parallel lines with it. So I'll meet you in the next video.